So in this video we are going to talk about angles. We will see each and every single topic that is tested on SAT Math when it comes to angles. Okay, now when we talk about angles, we should know about parallel lines. So I'm going to draw two parallel lines. These two lines are parallel, and I want you to make sure that when you're taking the SAT Math exam, never assume that two lines are parallel until it's mentioned specifically in the question. You might see two lines, for example, here I've drawn two lines, they look like they're parallel, but until it's mentioned specifically in the question, do not assume that they are parallel. Okay, so most of the angles questions are based on parallel lines. So let's say that we have L and M, and it's given that line L is parallel to line M, and then we have this line which is intersecting the line L and line M. This is called transversal. Now you can see that there are a couple of angles that are formed here. I can see 8 angles here. Okay, now these 8 angles are really important. So what we're gonna see is, if you see this angle and this angle, these two angles look like they are congruent. Okay, they look like they are congruent, and yes, they are congruent, and these are called corresponding angles. Okay, so what I'll do is I'm gonna name them. Let's say this is angle 1 and this is angle 2. So these are called angle 1 and angle 2. They are called corresponding angles. And they are going to be congruent to each other. So I will draw the congruent symbol here. Then similarly, on the left side of this transversal, we have another pair, this guy and this guy. So let's say that this is angle 3 and this is angle 4. So angle 3 and angle 4 will be also congruent. So angle 3 is going to be congruent to angle 4. They are also called corresponding angles. Then we see another pair which is called vertical angles, or they are also called vertically opposite angles. So this angle and this one, angle 1 itself. Okay, so let's say that this is angle 5. So angle 1 and angle 5 are your vertical angles. So angle 1 is going to be congruent to angle 5, and they are called vertical angles. So we can say that if angle 1 is congruent to angle 5 and angle 1 was also congruent to angle 2, so that means that angle 5 is going to be congruent to angle 2. And at some people also call angle 5 and angle 2 as alternate interior angles. Alternate interior angles. Now, similarly, your angle 3 is going to be congruent to this one. Let's call this angle 6. So angle 3 is going to be congruent to angle 6, because again they are vertical angles or vertically opposite angles. Okay, now angle 3 is congruent to angle 6, and angle 3 is also congruent to angle 4. So that means angle 4 and angle 6 will be also congruent. Angle 4 will be congruent to angle 6. Again, they are alternate interior angles. Okay, now if you see, angle 4 is going to be congruent to this guy. Let's say that this is angle 7. So angle 3 is congruent to angle 4 and angle 4 is congruent to angle 7. So that means angle 3 is going to be congruent to angle 7. And some people also call angle 3 and angle 7 as alternate exterior angles. So exterior because angle 3 and angle 7 are kind of outside these two parallel lines, and alternate interior angles are 5 and angle 2 because they lie between the two parallel lines. So angle 3 and angle 7 are alternate exterior angles. Okay, so this completes the different types of angles. Now there is one more property that you should know, that angles on the same side of the transversal add up to 180 degrees. So if you see the angle 2 and angle 6, angle 2 and angle 6, they are supplementary. They are going to be supplementary. They will add up to 180 degrees. So angle 2 plus angle 6 will add up to 180 degrees. Similarly, your angle 4 and angle 5 will be also supplementary, so they are also going to add up to 180 degrees. Alright, so let's do some practice problems. I've taken some practice problems from previous SAT exams. So here we have line L, M and N are parallel. So see, although these lines L, M, N, they look parallel, but you don't have to assume that they are parallel, okay? They will always mention this in the question. One thing that they will always mention that the lines are parallel. Do not assume it. Do not assume two lines to be parallel unless it is mentioned in the question. Second thing is, do not assume an angle to be a right angle only because it looks like a right angle, okay? They will mention it specifically in the question, or they will give you this right angle symbol, okay? Alright, so here line L, M and N are parallel. We have to find out the value of x plus y. Alright, so x is this, y is this. We have to find out the value of x plus y. Now if you see this line, this is a transversal, so I'm just going to name these points. Let's say that this is A, this is B and this is C. So if you see the transversal AB, and what I'll also do is I'm going to name this angle. So see, this 70 is this entire angle, this complete angle. 70 degrees is this complete angle, angle ABC, angle ABC. That is equal to 70 degrees. Okay, so we want to find out the value of x plus y. Now we know that the sum of two angles on the same side of transversal is 180 degrees. So if I say that this angle is angle 1 and this angle is angle 2, the small one, and now I know that x plus angle 1 is going to be equal to 180 degrees, because x and angle 1, they are on the right hand side of the transversal, they are on the same side of the transversal. And I can also say that y plus angle 2 will be also 180 degrees. So y plus angle 2 is also going to be equal to 180 degrees. And now we need to find out the value of x plus y. So what we can do is we can add these two equations. So we are going to get x plus y plus angle 1 plus angle 2 equals to 360 degrees. And we know that angle 1 plus angle 2 is nothing but 70 degrees. So this is 70 plus x plus y equals 360 degrees, and then x plus y is equal to 360 minus 70. So you're going to get 290. Okay, next we have this one. So it's given that line L is parallel to line M and we have to find out the value of x. Now here again, see, although the line L and M, they look parallel, but you don't have to assume it until it's mentioned in the question. Second thing is this angle, you see this square symbol, little square symbol. So this means that this is a right angle. Again, do not assume an angle to be a right angle unless either it's mentioned in the problem or this square symbol is given. Okay, so we have to find out the value of x here. Now I can see this little triangle forming here. So I'm going to name these points. Let's say that this is A, this is B, and this is C. So we can see that in this triangle ABC, this angle is 90 degrees, this is x, we need to find that out. So if somehow we can find out this small angle, then we'll have the two angles with us and we can find out the third angle by using angle sum property. What else, what other information do we have? So it says that L is parallel to M and this angle is given as 55 degrees. So if this is 55, then this angle, angle A, and this angle, they are actually nothing but alternate interior angles. Alright, this line is your transversal, this line. So 55 and this angle A they are going to be alternate interior angles, and alternate interior angles are congruent. So this angle is going to be actually 55 degrees. And now we can find out the measurement of x. So we know that x plus 55 plus 90 is going to be equal to 180 degrees. So x plus 90 plus 55 is going to be 145. This is equal to 180. So x is going to be equal to 180 minus 145. So x is equal to, well, 180 minus 140 is going to be 40. You subtract 5, you get 35. Alright, next I also want to talk about polygons. Although the topic of polygons is not considered, it's not considered as part of angles, but then I thought that polygons, I'm not specifically covering polygons in any video, so I decided to cover the topic of polygons in the video of angles. Alright, so polygons. So poly means many and gon means angles. Angles, or it also means sides. Well, it means angles basically. So polygon is actually a closed figure with many sides. Okay, so it can be a triangle is a polygon, a quadrilateral is a polygon, a pentagon is a polygon. So triangle is a closed figure with 3 sides, quadrilateral is a closed figure with 4 sides, pentagon is a closed figure with 5 sides, and so on. Now the thing that we need to know is that inside a polygon we need to know the sum of the measures of the interior angles of an n-sided polygon. So I'm just going to write it here. Sum of the interior angles of an n-sided polygon, and then we have sum of the interior angles of an n-sided regular polygon, and then we have sum of the exterior angles of any polygon. So a polygon can have any sides, so let's assume that for an n-sided polygon you should know what is the sum of all the interior angles. For example, if you have a quadrilateral like this, So the interior angles are this plus this plus this plus this. So sum of all these angles will be, let me change the color. Okay, so for an n-sided polygon, the sum is going to be equal to n minus 2 times 180 degrees. So for a quadrilateral, where n is the number of sides. So for a quadrilateral, n is 4, since a quadrilateral has 4 sides. So the sum of all the angles is going to be 4 minus 2 times 180 degrees. 4 minus 2 is 2, and 2 times 180 is 360. So sum of all the angles of a quadrilateral is 360 degrees. Now we have something called regular polygon, n-sided regular polygon. So regular polygon means that a polygon in which all the sides are congruent. Okay, so a quadrilateral will become a square or a rhombus. Square and rhombus, they both are regular polygons. Okay. Now this should be, actually I want to change this. This is gonna be measurement of each interior angle. Okay, measurement of each interior angle, because sum is anyway, it's gonna be 360. Sum, so measure of each interior angle of an n-sided regular polygon. So you know that the sum of all the angles is going to be n minus 2 times 180 degrees, and if you want to find out the measurement of one angle, then all you need to do is you need to divide this formula by the number of angles, right? So divided by n, because in a regular polygon each angle will measure the same. All the angles will be congruent. All the angles will be congruent. Okay. Then we have sum of the exterior angles of any polygon. So if you take any polygon and you find out the sum of exterior angles. So exterior angles will be, if you extend this side, if you extend this side, if we extend this side, and we extend this side. So we see a couple of angles forming now. This angle, this angle, this angle, and this angle. So sum of all these angles is gonna be equal to 360 degrees. It does not matter which type of polygon it is, whether it's a regular polygon, whether it's irregular polygon, how many sides it has, but sum of exterior angles is always 360 degrees. Alright, now let's do a practice problem. So here we have a regular pentagon. Again, do not assume a polygon to be a regular polygon unless it is mentioned in the problem. Now this pentagon, it looks like it could be regular, but do not assume that it's a regular pentagon unless it's mentioned in the question. Okay, so here it's a regular pentagon. We have to find out the value of x, and we have to find out the value of angle RQS. Okay, so since this is a regular pentagon, so we know that measurement of each angle, measurement of each interior angle is gonna be n minus 2 times 180 divided by n. That's gonna be the measurement of each interior angle. And in a pentagon we have 5 sides, so value of n is gonna be 5. So we do 5 minus 2 times 180 divided by 5. 5 minus 2 is 3. 3 times 180 over 5. So 180 divided by 5 will give us 5 times 3 is 15, and 5 times 6 is 30. And then 3 times 36. So 3 times 6 is 18, 1 carry over, 3 times 3 is 9, 9 plus 1 is 10. So x, value of x is equal to 108 degrees. Now next we need to find out the value of angle RQS. RQS is this angle. Okay, so now if somehow we can find out the value of this angle, this complete angle, angle PQR, then angle RQS is going to be equal to half of angle PQR. Angle RQS is going to be equal to half of angle PQR. You have to let me know in the comments that why angle RQS is going to be equal to half of angle PQR. Let me know in the comments. Now let's see how we can find out the value of angle PQR. Now this is again one very interesting thing in regular polygons. If you see, if I see that this entire angle is going to be equal to 360 degrees, and then this angle PQR is going to be equal to 1/5 of 360 degrees, because we can actually get 5 equal angles if I just extend this side and this side. So this will be divided into 5 equal angles: 1, 2, 3 and 4 and 5. So this angle PQR is going to be equal to 1/5 of 360 degrees. So 360 divided by 5 is going to give us 5 times 7 is 35, 1 and 0, 5 times 2. So angle PQR is 72 degrees. So RQS is going to be half of that, half of 72, which is nothing but 36 degrees. So that's it for this video for angles. So always make sure that do not assume an angle to be a right angle. Do not assume two lines to be parallel. Do not assume a polygon to be a regular polygon unless it is mentioned in the question. And you will be good. I think angles is a very easy topic. If you know just these facts, if you know what are corresponding angles, vertical angles, alternate angles, and this property that the angles on the same side of the transversal are supplementary. If you know this and the angle sum property of polygons, I think you will be good. These questions are basically gonna give you free points if you know these basic stuff. If you know these basic properties, you're gonna get every single angle question correct. That's it for this video. I'll see you in the next one. Till then, take care and all the best for SAT.